All right, so today is day 2 of our measures of central tendency. So our essential question is,
And variation.
Sorry. Our essential question is, how do I find variance and standard deviation?
So let's start by looking at this group of numbers. The
Okay.
data sets 19, 20, and 21, and 0, 20, and 40.
Okay.
We're going to prove to you right now that they have the same mean and median, but the sets are actually very different.
Mhm.
And how they're different is, well, they have different numbers in
Yeah,
them.
look at the numbers.
And it's how the data is spread out from the mean. Look at 19, 20, 21.
Right close to each other.
They're close, whereas 0, 20, and 40 are very spread out.
Yes.
The way that data are spread out from the mean or median is very, very important in the study of statistics.
Okay.
And what that's going to show, and then we'll come back to this, it's going to talk about a measure of variation.
Okay.
And it's a value that describes how spread out the data is. So let's maybe highlight a few things.
Okay.
The most commonly used measures of variation are range, interquartile range,
Which we talked about.
variance, and standard deviation.
Okay.
So we're going to talk about those in a minute, but before we do that, we're going to prove to you right now that the mean is the same on both. This is a good review on mean and median.
So mean, we add our numbers together
Mm-hmm.
and divide by how many there are.
Mm-hmm.
And we get
60 over 3, which is 20. Now we're going to find the mean of the other one.
So we do 0 plus 20 plus 40 over 3.
And that is 60
60
over 3, which is,
oh boy.
that's all
which is
right,
20.
20. Same mean.
Because that makes sense. 19 plus 21 is 40.
Exactly.
All right.
So the median we can probably just look at. I mean,
Yeah.
they're both in order. So look, the middle number, 20, 20. So we just proved to you the mean and the median are the same, but
Got
their
it.
spread of the spread, how spread out the data is
Yeah.
different.
Okay.
Here's some definitions for you. Variance is the average, that's the same thing as average mean, of square differences from the mean. Now, right now, that may seem like a lot of words, and we will demo what we mean by that.
We'll show you examples.
Standard deviation is really quite simple. It's a square root of the variance.
Oh,
Now,
that's
I'm going to have Miss Boyd right now
Yeah.
write the symbol for variance. Could
Oh,
you write that?
boy, I sure can try.
Okay.
So it's kind of like
Like
a
a
weird 6.
Yep, with a
And then
square.
squared.
That's the symbol for variance. So if you take the square root of that,
Oh, that
you're
just
going to
gets
get
rid
the
of the
standard
square.
deviation, which is
The weird symbol.
this weird symbol.
Okay. Yeah, just let it happen, Miss
I
Young.
don't like the way that goes up. It
that better?
has to have a little curl at the end. Okay.
It's her OCD kicking
It's my
in.
OCD. It's kicking in right now. Okay, that curve is good enough.
Oh, thanks.
I'm good. I'll be happy. I'll be happy. Oh, she's even gonna fix it for me.
Yeah.
Beautiful. The range. Miss Boyd is gonna write a little definition for you.
Great.
That is really the largest number minus smallest number. Pretty straightforward. And then the interquartile range, we're just going to write Q3.
Q3
minus Q1.
Which we did on the last video.
Yes.
Okay.
Let's go to the next page. And on the next page, here we go. The variance. Oh, and there's your symbol.
Crazy.
And denoted by sigma squared
Mhm.
is the average of the squared differences from the mean. Standard deviation is the square root of the variance. And is one of the most common and useful measures of standard deviation or variation. Now let's talk about this.
Okay.
A low standard deviation indicates that data is clustered near the center, whereas high standard deviation indicates that the data is very spread out. So if you are a statistician and you are looking at numbers, you want a low standard deviation.
Gotcha.
That means you have good data.
That means the numbers are close together. Like
clustered.
that first set we had.
Exactly.
19, 20, 21.
If your standard deviation is high, that means I would not put a lot of credibility into the numbers that you've collected, because that means numbers are all over the place.
Gotcha.
That's the key. Here is our steps that we are going to follow today.
Okay.
Step 1, we are going to find, this is the steps to find the variance.
Okay.
You're going to find the mean,
Okay.
which we know how to do.
Mhm.
Then we're going to find the difference between the mean and each data value and
Okay.
square it.
Okay.
And then the variance is just the average of all those squared differences.
So we're
That's
gonna
all
add
that
them
is.
together and divide by how many we
And the
have.
standard deviation is just the square
Square root.
root. So
Okay.
we're going to follow those steps right now.
Great.
And on a quiz or test, you must show all your work
Mhm.
because I know those lovely calculators will do this whole thing for you. But you can't do that.
No.
Here we go.
Okay.
Find the mean and standard deviation. So what I would like Miss Boyd to do in that first open box is I want you to write an X with a bar over it. I just lied to you.
Yeah.
An X minus an X with a bar over it. And you know what we're going to do on the side? We have to find the mean.
Right.
So that would be
can we
X
do that
bar.
right here?
You can do it right there.
Okay. So I'm just going to add them. 1 plus 2 plus 3 plus 4 plus 5 all over
5.
5.
And that is 15 over 5, which is 3. Can you set that equal to X bar so we know that that's X bar, which is the
Which is
mean?
the mean.
Yep. So now we can do this, right? Because now we're taking each X and subtracting the mean.
Got it.
So 1 minus 3.
Minus. Sorry, I'm just going to kind of color code here.
Oh, good. What is that? That's
Negative 2.
Yep. And 2 minus 3.
Negative 1.
And 3 minus 3.
0.
And 4 minus 3. Miss Boyd is so good at this
1.
writing.
Oh boy.
And 5 minus 3. 2.
2.
So on a problem, you will have to make this table.
Okay.
Now-
you don't have to show this work.
Oh,
you would just have to give us
goodness,
your
no.
answers.
Right.
Okay.
We're showing the work just so they understand.
Right. Yep.
Now, in the next open space,
Yes.
this is what Miss Boyd is going to
Yes.
write.
X minus the mean, but
Squared. So guess what?
So I'm just going to take this answer
Yep.
and square it.
Yeah.
So negative 2 squared.
Oh, you better be
Oh,
very
I better
careful.
put parentheses.
Oh, Miss
because
Boyd.
if you don't on some of your calculators, it'll be like, no, wrong answer. So negative 2 squared.
Squared. Notice her
is
parentheses.
4.
Negative 1
Negative 1 squared
is 1.
0 squared.
Is,
I didn't do parentheses because there's no
oh,
negative.
goodness, no. Yeah.
1 squared, again, no
You don't need parentheses because there's no negative. Right.
2 squared
Is
is
4. There we go.
Okay.
So we have already done step 1. We have already done step 2. This is step 3 now. So maybe let's write step 3 right
Okay.
down here maybe. Do you want, or
so it's
not.
kind of blocking a little. Like right here, maybe?
yeah, step 3.
Okay.
There we go. Good. All you're doing now, yep, exactly what Miss Boyd is doing. Adding up all of those numbers. The
Just kind of
average.
put in arrows so you
Yep,
know where I'm
it's
getting
the
those numbers
average
from.
of the it's the average of the
the
different squared. It
squares.
sounds a lot of words, but
All
over
over
5.
1, 2, 3, 4, 5. Okay.
when you add that up, you get 10 over 5, which is 2.
2.
That, right now, right, equals next to it is the sigma squared, which is the
Oh.
variance. There she goes again.
Oh, I didn't do my hook.
That's
Hold on.
okay. It's good. It's good.
Sigma.
good.
No,
It's good.
I gotta hook
okay,
it.
Okay. Write the word variance too.
Variance.
Good job.
Great.
Step 4.
We just square root it, right?
You got it.
So we'll take 2.
Square root it. And that is equal to 1.41. And that is equal to sigma. Here she goes again. Let's try the sigma.
Ah!
That is kind of bad.
Okay. Miss Young, you're supposed to be positive.
Positive enforcement. Here we go. I'm going to be. That is
Just go with it.
beautiful. It's
Just go with it.
beautiful.
Thanks. What's that
Equals
called?
standard deviation.
Standard
Yeah. Standard.
deviation.
I will accept that one.
Would you like to write
The
Miss
OCD
Young?
is bothering me just
Would
a tad,
you
but
like to write, Miss
I
Young?
will be kind to Miss Boyd
Would
because
you like to write?
she does so well, and yes, that is perfect. Nice.
Oh,
Okay,
boy.
circle 1.41.
I'm gonna just quick draw an arrow so they know where we got the 2
yes.
from.
Good job. Okay, so look at what it's asking. Find the
this
mean.
Is our answer.
We found the mean.
Okay.
Circle that because that's what it asked us to
Oops.
find.
Oh boy, what happened here?
Ooh.
Sorry, I accidentally got a little crazy.
Her OCD is kicking
Yep,
in.
it
now.
is.
Circle
Okay.
the 3.
So here's our 3.
That's the mean. And
That's it.
circle the standard deviation. Oh, she did.
I did.
That is it, you guys. It's really pretty straightforward.
It's just a lot of steps, but it's
Yeah.
really easy. You can
I
do it.
think I know. We have faith in you all.
Okay.
Example 2 is on the next page, and if I recall,
We're gonna save it.
we're
for
gonna
class.
save it for class.
Okay.
Ooh,
Ooh,
we
well,
got to talk about
yes,
this,
the
okay?
Outliers, yep.
An outlier is an extreme value that is much less than or much greater than the other data values.
Okay.
So remember we talked about low standard deviation,
Mhm.
high standard deviation. If you have outliers, your standard
be high.
deviation is going to be high.
Okay.
So-
And so kind of just an
Mhm.
example.
Yeah.
Let's just say, so say we have like 0, 1, 2, and then 75. 75
It's
would be our
pretty
outlier.
obvious. You got
Okay.
it. So outliers have a strong effect on the mean and the standard deviation.
Yeah.
If an outlier is the result of measurement error or represents data from the wrong population, we usually remove it.
Okay.
There are different ways to determine whether a value is an outlier. One is to look for data values that are more than 3 standard deviations from the mean. And we're going to talk more about that in class. Oh, where did this come from?
I don't know.
Oh,
I think we skipped it. That's why.
oh, find the mean. Oh, this, I think this is one, I
Yeah.
think we have to save this for
I
class
think so too.
because this is one where actually we are going to show you how to do it in
On
your
the
calculator
Yeah.
because there's so many numbers.
Yeah, and decimals.
Oh, and
and
my table
and
didn't,
your
we got to
table
fill
didn't
it.
show up.
Yeah,
We'll
okay.
fix that.
All right. So go to the next page. And we're going to do both of
Yeah,
those in
in
class. And so
Great.
this is, here we go. Find the
Wonderful.
variance. You can do that. Find the mean, median, and mode. That's a review of day 1.
Yeah.
We
See
can
you
do this.
tomorrow.